So here are the some repeating decimals. Now 3 divided by 11, if you were to do this one by hand using long division, you would actually see that there are, it goes a decent ways before it actually starts repeating. So let's just look at the, oh wait, no, never mind, not 311, so I was thinking a different one. This doesn't go that far, never mind. This just oscillates between 2 and 7. You can see on my calculator, this last digit, it says it's 3, but that's because it rounded here. This would have been a 2, then a 7, thus rounding up and making that a 3. So in any case, this is 0.27 repeating. The bar over the 27 means both the 2 and the 7 repeat. An interesting thing, how about something if I wrote it like this, 2.72 with a line over the 7 and the 2? Would that be the same number? Or would this one, 272, would that be the same number? Or maybe 2727, would that be the same number? Well, let's look to see what they would end up giving you. This first one, 0.272, well, it's the 72 that's repeating, so it would keep going 7272. Dot, dot, dot. And that's exactly what we're talking about here, 272727. So that is the same sequence. That's the same thing. I could have written it that way. It's a little weird way to write it, but I could have. This one right here, 272 with a line over it. This is saying we get 272, and it's the 272 that repeats. 272, 272. And you'll notice that there is a difference here. This one doubles up on those 2s. It goes 272, 272, 272. This is not the same thing, so that would not be the same one. And this one, well, it's kind of silly to have a repeating sequence within your repeating sequence, but you could do 0.2727, 2727. That one is the same thing as well. So even writing 2s and 7s with that repeating bar, you can get things that are or are not equal to the number you're looking for, so just be a little careful with that. All right, let's look at 17 divided by 7. This is one where, at first glance, this may not look like it's repeating at all, because on this calculator, we get 428,571,429. Well, if you recognize that this is actually an 8, and the next digit would be a 5, you can kind of see that there is 42857. 428,571 rather, there is that sequence that repeats. It's actually 6 digits. And there's a reason why that's actually the most. If you're dividing by 7, that's the most that you could have a repeating sequence of. Yeah, whatever, I'm not going to get into that. In any case, what was this? 2.428571 repeating. And that entire sequence repeats, so I'll do the bar over all of it. And then we'll do 41. 41 divided by 33 gives us 1.24242424. 1.24. It's the 24 that's repeating. And when we're talking about these repeating bars, you'll notice we'll never do, even if I had something like 3.3 repeating, I would never write this as 3 like that, or maybe 3 decimal or something like that. When you have a repeating bar, it always needs to be to the right of the decimal place. We actually use that over bar, the bar over the digit. We use it somewhere else that you'll see in this class. But for now, yeah, this over bar, just know that when it's talking about repeating sequences of digits, it will only be to the right of the decimal. If you had it to the left of the decimal, then that's like having, okay, well, it's saying 3 is the same as, well, how many 3s do I go before I do my decimal place? Do I do 2 3s before I do my decimal? Or 4 3s before I do my decimal? It just doesn't work if you do the repeating bar on the left-hand side of the decimal. It only works on the right-hand side.